Hello students. Now today's topic is balancing chemical reactions. Yesterday I told you why should we balance a chemical reaction. According to law of conservation of mass can neither be created nor destroyed in a chemical reaction. So there is a need to balance the number of atoms taking part in a chemical reaction. What is a balanced chemical reaction? I'll write a reaction, a simple reaction over here. Hydrogen plus oxygen, it gives water. It's a very simple reaction. Now let us see how do we count number of atoms taking part in this chemical reaction. Here hydrogen has 2 atoms, oxygen has 2 atoms, and in product 2 atoms of hydrogen and 1 atom of oxygen together form a molecule of water. But if you see reactants and the products, on both sides atoms are not equal. Here oxygen 2 atoms, but here this side we have only 1 atom of oxygen. We'll have to balance it, right? So how do we do this? So what we can do actually, balancing a chemical reaction is a hit and trial method. But we can follow few steps to make balancing convenient. What we can do is, we can start balancing with the compound that contains the maximum number of atoms. But in both cases, we can see hydrogen. Of course, hydrogen is balanced here on both sides, but oxygen is not yet balanced. So what am I going to do? I will increase coefficients here. Okay. So what will I do? I will not make any difference or any change in its atom. Rather, I will increase coefficient. What does that mean? Say for example, if I write H2O2, it means I am increasing number of atoms over here. This compound is water and this compound would be hydrogen peroxide. So it's wrong. So then what should we do? We will increase, or we will write coefficient, right? So to make it 2, I will write 2 here. So while doing so, oxygen become 2. Now this oxygen and this oxygen is same, right? So atoms of oxygen on both sides become 2. But here, while doing so, hydrogen become 2 into 2, 4, right? So now here, reactant side, we have hydrogen, 2 atoms of hydrogen over here. So to make it 4, I will write 2 over here. Finally, hydrogen 4 atoms, oxygen 2 atoms. Here hydrogen will have 4 atoms and oxygen 2 atoms. Now this is a balanced chemical reaction. So I'll give you another example. CH4 plus O2. it forms carbon dioxide plus water. Now let us count number of atoms taking part in this chemical reaction. This is methane, it's a molecule of methane, right? So here carbon 1, hydrogen 4 atom, correct? Oxygen 2. Here in product side carbon 1, oxygen 2 and hydrogen 2, oxygen 1. So if we see on product side we have oxygen 2 plus 1, 3. But here we have oxygen 2. So this is unbalanced or skeletal chemical reaction, right? So to equalize the number of atoms on both sides, we'll have to balance this. Now first of all, we need to identify the number of atoms taking part on right hand side and the product form on the left hand side of a chemical reaction, which we have done. Now let us balance it, right? So I can choose, I can start from hydrogen. Shall I start from hydrogen? Because hydrogen here have maximum number of atoms, 4. So I'll begin from hydrogen. To make hydrogen 4 this side, what will I do? I will increase, I will write coefficient here. By doing so, hydrogen becomes 4. Okay. And oxygen also becomes 4. Oh, sorry, I'm sorry. Oxygen also becomes 2. Right? Now, let us check carbon. Carbon is okay. Both sides it is 1. Hydrogen also becomes 4. Right? Oxygen is 2. But here oxygen, if you check, 2 plus 2, 4. So, here also we'll have to make 4. So, I will put 2 here to make it 4. So, if you count atoms on both sides, you will see both are equal on right hand side as well as on product side as well as on reactant side. Carbon 1, carbon 1. Hydrogen 4. Here also hydrogen 4. 2 into 2, 4. Oxygen 2 into 2, 4. Here oxygen 2, 2, 2 plus 2, 4. Now this reaction is a balanced chemical reaction. I'll give you another example. AgCl. This is silver chloride, and this reaction takes place in the presence of sunlight. And compound form is silver plus chlorine gas. Okay. Another very simple reaction. Now let us identify number of atoms on both sides. In silver chloride, 1 atom of silver, 1 atom of chlorine. In silver, here silver has 1 atom over here and chlorine 2 atoms. Right? So this is not a balanced chemical reaction. It's very simple. What will I do? I will not put 2 here. That would be wrong. If I do like this, it would be wrong. So what will I do? I will write 2 over here. While doing so, now let us see the number of atoms change. Silver, 2 atoms. Chlorine, 2 atoms. Here, chlorine, 2 atoms already. So it means now chlorine atoms are balanced on both sides. So to make it silver 2 or balance, what I am going to do, I'll put 2 here. Now if you check all these atoms which are taking part in the chemical reaction on left hand side and the product formed on right hand side are equal. Now I will take the example which is given in your book for teaching balancing chemical reaction. It's a reaction of iron with water, and it forms iron oxide Fe2O3 plus hydrogen. Right? Now let us identify the number of atoms taking part in this chemical reaction. Iron, 1 atom. Hydrogen, 2 atom. Oxygen, 1 atom. This side, iron, 2 atoms. Oxygen, 3 atoms. And hydrogen, 2 atoms. Right? Now what do I do? From where I can start with? Right? If you just have a complete careful look in the whole chemical reaction, from where do I start with? Now I will start with the maximum number of atoms in any molecule or in any compound which we find in the chemical reaction. Now in case here oxygen 3, right? So let me begin with 3. I can begin with iron as well, but I would like to begin from here. Okay, it's convenient to start balancing with the compound that contains the maximum number of atoms. So I will choose oxygen, right? To make this oxygen 3, I will write coefficient 3, right? Now let us see what change takes place. Here 3 into 2, hydrogen also becomes 6. 3 into 2, 6. And oxygen becomes 3. So oxygen is balanced here. Am I right? It is balanced. Now oxygen here is oxygen here also. Oxygen is 3. Now hydrogen has become 6. To make this hydrogen 6, I will write 3 over here. Right? Now it becomes 6. Now what is not balanced here? Iron. So here iron 2 atoms. So I will put 2 over here. Now if you check this whole chemical reaction, you find this reaction is balanced. Iron 2 atoms. Fe2 2 atoms. Hydrogen 6 atoms. Hydrogen has become 6 this side. 3 into 2, 6. Oxygen 3. And here also oxygen 3. Children, there is no method or there is no hard and fast rule to balance a chemical reaction. But as a matter of convenience or for the sake of convenience, we start balancing those atoms which have large number of or which have more number of atoms. In this reaction, oxygen has 3 atoms. In this compound of iron oxide, oxygen have 3 atoms here. So I started from here, right? So now, what we can say, balancing a chemical reaction is a hit and trial method, right? So one need to practice, and it comes with practice. Now I would like to take a reaction, another reaction. It's a reaction of aluminium element with water, and it gives aluminium oxide Al2O3 plus hydrogen. Now in this case, let us identify quickly the number of atoms taking part in this chemical reaction. Aluminium 1, hydrogen 2, oxygen 1. In product, 2 atoms of aluminium, 3 atoms of oxygen and 2 atoms of hydrogen. Right? Now let us balance this reaction. We can start again with oxygen here. Oxygen is 3 here this side, so I'll write 3 here. Okay, so oxygen becomes 6, hydrogen becomes 6, and oxygen is balanced. Right? Aluminium 2 atoms. To make it balanced, on reactant side I will make 2 aluminium. Now if you check hydrogen, hydrogen has become 6. Here hydrogen is 2. I will write 3 here and it becomes 6. Now if you check this chemical reaction, it is balanced. Aluminium 2 atoms, right? Hydrogen 6, oxygen 6, hydrogen 6 this side, and on product side it also has become 6, and oxygen 3 this side, right? Oxygen is 3 this side, and here also oxygen 3. Oxygen 1 atom, 3 into 1, 3. So this is how we can balance chemical reaction. Now I'll give you one reaction to make you understand where there is compound formed. For example, I take an example. Of this reaction. So this is nitric acid HNO3 plus CaOH whole twice, and it forms calcium nitrate whole twice plus water. Right, now how we will calculate or count number of atoms taking part in such compounds. Right, now let us see. Hydrogen 1, nitrogen 1, oxygen 3. In calcium hydroxide, this is CaOH whole twice. Calcium 1 atom, oxygen 2 atoms, because their OH is in parenthesis. Hydrogen 2 atoms. Here this side calcium 1 atom, nitrogen 2 atoms. Okay, and oxygen, just see clear, watch clearly. Oxygen 3 atoms, and it is in parenthesis, and here it is twice. It becomes 3 into 2. So oxygen becomes 6. Got my point? Watch this. Calcium 1 atom, NO3 whole twice. Nitrogen is double. Oxygen is also double. Since O3, it becomes 3 into 2, 6. Then hydrogen 2 and oxygen 1. Right? Now check whether these atoms are equal on both sides. Hydrogen 1 this side, hydrogen is 2 this side. Is it? No. Actually, hydrogen is 3 this side. 1 plus 2, 3, right? But in case of this product side, we have hydrogen 2, right? Now here we have calcium 1, the nitrogen 1, and nitrogen here this side is 2. Oxygen is 3 this side. In this atom of nitric acid, we have 3 oxygen. Here it is 2. So it means 3 plus 2, 5 on reactant side. Here 6 plus 1, 7. So this is highly unbalanced reaction, isn't it? So we have to start. Now let us see from where we can begin with. I do not know how to do it. Let us check how can we do it. Together let's do that. Now here I think I should begin with this compound, calcium nitrate. Okay, so I want to make nitrogen twice, so double, like here nitrogen is 2. So to make this nitrogen balance, I will write 2 over here without looking at any other thing. Just I pick an atom of nitrogen this side, it is 2, so I put 2 here. Now let us see what changes take place. Hydrogen become 2, nitrogen become 2, oxygen becomes 6, right? So 6 plus 2, 8, right? Isn't it? So now let us count actually. Again, if we count, hydrogen is 2 here, hydrogen is 2 here, it means it has become 4, total become 4, right? And here we have hydrogen 2. So I just look at hydrogen and I just blindly put 2 over here to make it 4. Since my nitrogen is balanced, I have already balanced nitrogen. Now I have balanced hydrogen as well. You see, here 2, here 2. So it is 4. Now hydrogen is also balanced. It has become 4, right? And nitrogen is 2. So nitrogen is 2. Now let us check once again what difference we have made. So hydrogen is balanced here. Okay. Calcium was already balanced. Now here hydrogen has become 2 and 2, 4. Here hydrogen has become 4. Oxygen 2. 6 oxygen we already had. So total oxygen had become 8. 6 plus 2, 8. Children, please see this. Here in these two compounds, in these molecules, we have plus sign. This is water. This is a compound of calcium. And between these two, we have plus sign. So number of atoms will also get added. So oxygen 2, here oxygen 6. So total oxygen become 8, right? Here oxygen was 2 and now we have made 6. So 6 plus 2, 8. So oxygen is balanced. Nitrogen and hydrogen was also already balanced. Calcium was already balanced. So this is a balanced chemical reaction. Right? Is it difficult? Not really. So today you do write down all these examples. Okay. Note it down in your notebook systematically. I give you few examples, some problem, kind of assignment rather I should say. So you note down all these chemical reactions. I hope they are clear. You may note down these chemical reactions and try to balance them. In next class, I will give you answer for them. And if you have any doubt, please do send it to me. So bye for now. Stay at home and stay safe.